2 is it's an even number. So it has to end in 0, 2, 4, 6, or 8. So for example, a number like 439, I'm sorry, let me actually change that. Let's do it this way. 738, it ends in an 8, so this is divisible by 2, as this one works. But a number like 641 does not work.
Okay.
Okay. Now we're just gonna do a couple of rules here, and then we'll look at some fractions.
Okay.
All right, so here's the next one. I want us to at least have the rules for 2 and 3. Okay, so the sum of the digits is divisible by 3. So what do I mean by that? Well, let's take a look at a number like 15 that we know is divisible by 3. What is 1 plus 5? That's the sum of the digits. Sum means you're going to add them. 1 plus 5 is 6, and 6 is divisible by 3. Okay. Let's take a number that we know does not work, like let's go 29. 2 plus 9 is 11. 11 is not divisible by 3. Okay.
Okay.
All right, so we're gonna leave it at that. Then we'll get a few more rules going, but let's look at a couple of fractions here. So let's say I give you the fraction 4 over 10. And the instructions would say to reduce. Okay, so you're looking for a number that divides both the top and the bottom, and you generally start with 2. Okay, so is 4 divisible by 2? Yes. So can you divide that top number by 2? Yes, you can. 4 divided by 2 is 2. 10 divided by 2 is 5. All right. And you generally try this divisibility again, but we'll do some simple examples here. So these will just be ones. Let's try another. How about 8 divided by 20? Okay. So is 8 divisible by 2? Is it even? Yes.
So I have to divide?
Yes, and the bottom is also divisible by 2. Now they have to both be divisible by 2.
Oh. So, it's 2. So 8 divided by 2 is... Wait, sorry.
Yeah, 8 divided by 2 is what? 4. Okay. And how about 20 divided by 2?
20 divided by 2 is...
So another 10, yes. And again, another way you can do that is you can say 2 times what number, which is 10, is 20. Okay, now this is where you try it again. You say to yourself, well, I wonder if 2 goes in again. So you try dividing the top and bottom by 2 again. And we know from the previous problem that this works. 4 divided by 2 is 2. 10 divided by 2 is 5.
Okay.
Okay, so let's try another one here. Let's go 6 over 18. And the instructions say to reduce or simplify, could say simplify. All right, now we try 2. Now we know 2 works because both of these numbers are even. That was our divisibility rule for 2. Okay, so can you divide both of these by 2 for me?
Okay. divided by 2 is 12.
You're dividing, so it has to get smaller.
Oh. So 2 divided by 6 divided by 2. Um 6 divided.
Division by 2 is like cutting the number in half.
So what is that supposed to mean?
Well, this is something you're supposed to know already. I mean, we can't do much of this lesson. I mean, we've talked about this for a couple of weeks now. The other way to look at it is 2 times what number equals 6.
Oh, okay.
What number is that?
That is 3.
Okay. And how about 18 divided by 2 or 18 cut in half?
Okay. So that is
So 2 times what number equals 18?
Is it 9?
It is 9. Okay. All right. Now notice both of these numbers are odd. So we can't divide them by 2. So the next number you try after 2 is 3. Are they each divisible by 3?
So is 3 divided by 3 is 2.
So the other way of asking it is saying 3
wait.
times what number equals 1. And if you're not doing this, writing it down, you really do want to do that.
Yeah.
I'm sorry, 3 times what number is 3?
Yeah, it's 1.
It's 1. And then it's the same thing for the next one. Now, I'm not going to write it, so I want you to write it.
Okay.
And give me the right number here. 3 times what number is 9?
So, oh yeah. So it is
Do you have an answer for me?
no.
Okay. What did you write down over here?
I
Or
write
kind of,
9 times blank equals.
okay, but that's not what we've been doing over here. We've been taking the second number. The 9 goes over here on the right. You've got to map where we're putting the numbers. Like, See how 18 is over here on the right, and then the
Yeah.
2 is over here. So it's 3 times what number equals 9?
Oh, okay. Three times. It's 3 times. It's 3, right?
Yes. Yes. Okay, I've got to get you to do some of this on your own, because if I keep doing the examples, it doesn't help you in the end. So let's try another one here.
Yeah.
Okay, same instructions. I mean, all I'm doing is changing the numbers. You're gonna do the exact same thing here. Let's go 30 over 42. What number do you always try first when you're reducing fractions? It's the same number we've been trying in every single problem.
3.
Let's go back and look. What number did we try first here?
We tried 6. Oh, 2.
And how about in the previous problem?
2.
How about in the previous problem?
2.
Okay, so what is the first number we're going to try?
2.
Yes, you always try 2 first.
Okay.
So I want you to divide each of these by 2. Now, these numbers are getting a little bit larger, but again, dividing by 2 is like cutting in half.
Yeah.
Cutting in half. Okay, it's like splitting between 2 groups. Okay, if you need to, you can write 2 times what number equals 30, but I think it's easier to just try to recognize, well, what's half of 30?
Half of 30. Is it? Wait, let me just do it a little. I don't know this one.
Okay, so you have to make a guess.
Okay.
How old are you?
10.
10. So what is 2 times 10?
It is 20.
Okay, so it's bigger than that. So we'll pick another number.
2 times.
Pick a bigger number.
11.
Okay, it's got to be a lot. It's got to be more. It's choosing
Okay.
one it's too close. You're guessing, and guessing you don't want to just choose the next number, because I mean that's a slow way of guessing. So give me a number bigger than 10,
Okay.
but not 11. And please don't say 12.
16.
16, great. So 2 times 16 is 32. Okay, that's just a little bit too big. So what's a number that's a little bit smaller than 16? That might work.
14.
2 times 14 is 28. So it's got to be between 14 and 16. What number is that? What number is between 14 and 16?
2.
What number is between 14 and 16?
6.
I'm sorry?
Oh no. Is it 10?
It's between. Do you understand the word between, like in the middle?
Oh. Between.
Yeah, between your 14th birthday and your 16th birthday, what birthday will it be?
14.
That between. Between means it can't be the endpoints. It has to be something in the middle.
15.
15. Okay, so 2 times 15 is
30.
30. So there's the number, 15.
Okay.
Okay, so do the same thing with 42, and you're gonna have to make a guess. I mean, you probably don't have your 42 times table memorized all the way up to 42, but you should be able to make a guess. You should say, well, it's bigger than 10, but it's actually, no, it's bigger than 16 because 2 times 16 is 32. So pick a number bigger than 16 and try to figure it out. There are some other techniques we can use, but also some self-discovery is good at this point as well.
Yeah, I'll work on it. Okay.
How are you doing on this one?
I'm doing. So, am I supposed to?
Well, what numbers have you tried?
I tried 2 times. No, 2 times 17.
Okay, and what is 2 times 17? What did you get for that?
34.
Okay, 2 times 18 is 36. What is the pattern here?
That it's 2 counting.
It's going up by 2 each time. So we go 38, 40, and then 42. So what is the pattern over here on the left? What is it going up by?
1,
Okay, so that's 19,
19, 20,
20,
21.
and 21. Okay, so 42 divided by 2 is 21.
Oh.
Now, we would normally try 2 again, but both of these numbers are odd. So 2 will definitely not work. But the question is 15, can you divide 15 by 3? Let's go back and look at the divisibility rule for 3. The sum of the digits is divisible by 3. So you got to add up the digits. You've got to add up the digits here. 1 plus 5. 1 plus 5 is 6. Okay.
Okay.
Is 6 divisible by 3? Yeah, absolutely. And 21, 2 plus 1, well, that equals 3. That's also divisible by 3. So you can divide both of these numbers by 3.
Okay.
So give that a try. And again, if it's not clear what it is, you can always write as 3 times some number equals 15, but pay attention to where the numbers go. See how I'm putting 15 on the right?
Yeah.
So you got to figure out what number you multiply by 3 to get 15. That goes in the top. What number you multiply 3 to get 21. Okay, so give that a try, please.
So 3 times
3 times what number gets you to 15?
5.
Okay. How about on the bottom there?
On
3 times what number gets you back to 21?
so it's 3 times it's 3 times 7, right?
That's correct. Very good. Okay, so the good news is that pretty much through our part of the lesson today, I want to just spend a couple more minutes with you, but you can see how important the knowing your multiplication table is. You really want to be solid on that.
Yeah, my auntie actually did a multiplication table for me, and
Okay,
I'm on that right now.
great.
So
You wanna look at it, stare at it, look for patterns, and find time to look at it every day. That will really help. But let's look at one more divisibility rule. So a number is divisible by 5 if it ends in either 0 or 5. So for example here, 15
mhm,
15 is divisible by 3. We already know that. We've looked at that a couple of times because 1 plus 5 is 6. But because it ends in 5, it's also divisible by 5. Okay. Let's take a number like 25. It's divisible by 5 for the same reason. Okay. And a number like, let's take a much larger number like 12,395. It is also divisible by 5 because it ends in 5. Can also end in 0. So like a number like 10, which is divisible by 2
mhm.
because it's even, it's also divisible by 5. All right. Now I'm going to send you a link in the notes here. I'm going to send you a link to my this reference sheet,
Okay.
and just stand by here for a moment. Let me see if I can get to that quickly. It will help you to what I would recommend is printing it out and
Yeah.
and looking at it too. Divisibility rules are really designed to be used with division as well as reducing fractions here. So give me just a moment here. Here it is, copy link address. I'm just gonna throw that in the chat to you. to Zoe. There you go. That should be available after the lesson, but good job today. I'm going to go ahead and mute you and bring your brother in.
Okay, thank you.
You're welcome. Hey, Michael, how are you?
Good.
There is a lot of echo. Maybe turn down the volume there. Just a tiny bit. Hope you're doing well.
Yeah.
I can still hear a lot of echo. Are you able to reduce the volume, or maybe you got a headset handy? That would really help.
What about now?
It appears to be better. I'm going to go ahead and there you go. Yeah, that's okay. That sounds good as long as you can hear me. So your dad sent over some sample problems for us to look at today. All right. Still doing a lot of expressions, and that's going to be, we had some issues with that last time. Your dad also sent a login for us to do. Maybe I'll check that out if that's okay. Give me just a moment here to log in. Do you have some pencil and paper out for us to work on today? Take some notes. Assume you do.
Yes.
All right, just stand by for me here. I'm gonna log in real quick and see if I can quickly find something. If I can't, we'll just kind of go with what we did last time. How is school going? Are you feel good about it?
It's okay.
All right. Do you feel like you're behind?
No.
Do you feel like you're on schedule?
No.
No. Okay. All right. So here I see you got your math class. I'm just logging in here, and looks like you've completed a bunch of units. That's good to see here. Multiples and factors. Okay. Yeah, I was able to access this lesson. I'm just trying to see what you're working on. And they give you a lot of information, but where are the actual questions? Okay, let's just look at these together. This would be good for us to do. And you can tell me if you've already looked at these. So if you're seeing my screen, do you see my screen? Which statement are true about this pattern?
Yes.
Okay, so let's look at the pattern here. I see a circle, a triangle, a heart, circle, a triangle, a heart, and so on. They're also all the same color. Okay, so let's look at each statement one at a time. Is a triangle always between a circle and a heart? See how there's a triangle here. There's a circle on the left. There's a heart on the right. Is it true that there's always a triangle between a circle and a heart? Do you agree with that statement?
No.
Okay, so if you don't agree with it, tell me where there's a triangle that does not have a circle and a heart around it. And what I'm trying to do here for you is frame the pattern. Look at the first three numbers in the pattern there. Is the triangle between a circle and a heart?
Yes.
How about in the next pattern? Is there a triangle between a circle and a heart?
No.
It's not?
Here.
What is this to the left here? What would you call this one?
A circle, triangle, and a heart.
So is the triangle between a circle and a heart?
Yeah.
Okay, I agree. How about this? Circle, triangle, heart. Is the triangle between a circle and a heart?
Yeah.
Okay, so it looks like that's true. Let's compare that to the next question. Next one. A circle is always between two hearts. Is a circle between two hearts? So sometimes to do these problems, you have to actually kind of reestablish the pattern here. I'm going to do that by snipping it and putting it down here. So look for the circles. There's a circle, there's a circle, and there's a circle. Is it always between two hearts?
No.
No. So I would agree, no. Now, is it true that a heart and a circle are always between two triangles? So this is where you got to say, okay, where's my triangle? There's a triangle, there's a triangle, and there's a triangle. Is there always a circle and a heart between them?
Yes.
That looks good. A heart is always to the right. A heart is always to the right of a circle. So there's your circle. There's your circle. There's your circle. Is there always a heart to the right of it?
No.
It doesn't look like it. Okay, so we would say no to that one. Any questions on that pattern?
No.
Okay. All right, let's look at the next question. All right, so one of the things that I'm going to try this time is I'm going to throw up the question without us looking at the answers. Sometimes looking at the answers can actually work against you. So it says a number pattern starts with 3 and follows the rule add 4. So Michael, what number does the pattern start with?
A circle.
Don't guess. It's right in here. I promise you. I always give you enough information to be able to answer the question. Read this part out loud for me, please.
A number pattern starts with 3 and follows the rule and number 4.
Right. So if this were multiple choice, there's two possibilities. It either starts with 3 or it starts with 4. Which one does it say that it starts with?
3.
3. Now the rule add 4 means you're going to add 4 to this number. Can you tell me what 3 plus 4 equals?
6.
Try again.
7.
7. How about 7 plus 4? What does that equal?
11.
Okay, good. How about 11 plus 4? Michael, are you with me?
15.
Good. Excellent. Okay, what is 15 plus 4?
Uh, 19.
It is 19. Perfect. Now, how many numbers does it want us to write in the pattern?
19.
Let's go ahead. Can you go ahead and read this for me out loud again, please? The second sentence.
What are the first 5 numbers in the pattern?
Okay, so it tells us there, how many numbers in the pattern does it want you to determine?
4.
What number is this right here?
5.
So do we have the first 5 numbers? 1, 2, 3, 4, and 5.
Yes.
Good. Okay, now the next part of this, and this is the part that I think could be a little bit difficult, is if you see the answers first, which of these, and let's call them A, B, C, and D, which of A, B, C, and D match up with the pattern you just gave me?
D.
Very good. I agree. Oop. Hang on just a second. My screen just froze up. There we go. Excellent. All right. Okay, let's look at the next question. All right. So actually, I'm gonna do something different. I don't want to present the questions. I think it might bias you, but I actually, no, I take that back. Let me snip it in here. Okay, what is the rule for this pattern? So let's look at this pattern here. The pattern is 28, 26, 24, 22, 20. So I notice the numbers are getting smaller. So the math operations that correspond to getting smaller would be subtraction and division. If the numbers got larger, it would either be addition or multiplication. And my question for you, Michael, is are these going down by the same amount each time?
E. Yeah.
I agree. Now, how much are they going down by each time?
2.
So the rule it would be subtract 2. When they're going down by the same amount, that's subtraction. When they're going up by the same amount, that's addition. All right, let's look at another question here. This question says, what is the next number in this pattern? Okay, that means you, Michael, have to figure out the pattern. What's going on in this sequence here? Now I notice that the numbers are increasing. They're getting bigger or larger. All those are the same for our purposes. Can you tell me the rule? Can you tell me what is going on here? Are they and the 2 options are there's either an addition, you're either adding a number each time or you're multiplying each time.
Multiplying.
Okay, so what do you multiply 6 by to get 10? And you're allowed to change your answer. Maybe now you're saying maybe it's not multiplication. Maybe it's addition.
Yeah. Probably addition.
Okay. So what are you adding each time?
4.
4. I agree. So you're adding 4 each time. So I want you to add 4 to 22 to get this last number.
26.
Yes. Perfect. Excellent. All right, so I'm going to post the next question here, and I want you to see if you can do it on your own. So So take a few moments here and see if you can work on this and come up with the right answer.
$19.
Okay, so before I tell you whether you're right or wrong, what is the pattern here? And you notice the numbers are getting smaller. Okay, so you actually don't even need these. You notice they're getting smaller. When they're getting smaller, there's two possibilities. You're either subtracting or you're dividing. But they look like they're going down by the same amount each time. What are they going down by?
$6.
I think they're going down by less because 30 minus 6 is 24. And we want to get to 27.
$5.
You're just guessing at this point, Michael. Another way to look at it is how do you go from 27 to 30? What do you add to 27 to get back to 30? You're adding 3. Okay, so now to go the other way, you subtract 3. 24 to 27 is adding 3. 27 to 24 is subtracting 3, and so on. So we're subtracting 3 each time. So what is 21 take away 3?
$17.
No, try again one more time.
$18.
18, perfect. All right. Okay, well, Michael, I'm going to talk to your dad if he's around. Give him some feedback on today's lesson. Thank you so much.
Do you want me to pass him to you? Because he's in his room.
Well, you know what? I'll give him a call and I'll give him some feedback later on.